When a solar inverter goes offline, the O&M team typically finds out from an end-of-day report, or worse, from the customer calling to ask why their generation dropped. By the time a technician is dispatched, the site has lost a full day of production. And ordering spare parts? That's a phone call to a supplier, a manual quote, and a purchase order process that adds another week of downtime. This module closes that loop. The machine learning models detect faults in real time, diagnose the root cause, recommend specific actions, and lets you build a bill of materials and schedule the repair, all in one place. It also produces day-ahead generation forecasts, so you can see tomorrow's expected output before it happens. The performance dashboard shows you the fleet snapshot for Sibaya Casino, which includes 7 Huawei 330 KTL inverters and a total of 2.31 megawatts. Also on display is the current state uptime percentage, number of kilowatt hours generation, target attainment percentage, total number of active devices, and performance ratio of your assets. 6 out of 7 inverters are online, with 3 open alerts and 1 being major. The asset breakdown table helps you track the specific details of your devices. Per inverter breakdown, Inverter 5 shows a fault status at 94.2% uptime and 88.7% target attainment. Now, that's our problem child. The maintenance sidebar on the left is where the machine learning pipeline surfaces what's wrong and what to do about it in the OODA loop alerts. The Sibaya site currently displays 3 alerts. Inverter 5 shows a major alert where a fan stall has been detected and triggered a terminal shutdown. The energy at risk is 112.4 kilowatts and 83% confidence in detection. Inverter 4 shows a moderate alert. The production is below expected performance, and there's a possible string degradation resulting in 58.2 kilowatts at risk. For Inverter 6, there's a minor fault caused by intermittent communication, where the device goes offline due to unstable network. To ensure the device is operational, the following actions have been recommended for Inverter 5. Your P0 action is to dispatch technicians for fan replacement, and P1 action is to notify operations about the device status. You can click Approve and Schedule to create a maintenance plan directly from here. The fan replacement for Inverter 5 is already in progress and has been assigned to SIPO, the foreman on site. The BOM Builder tab lets you select specific paths from the SKU catalog, calculate the material plus downtime costs, and set an installation date based on lead times. In the Day Ahead Forecast sidebar, you can view tomorrow's generation forecast and weather summary. For this site, the expected generation for tomorrow is 2.1 kilowatt hours with 92% confidence of plus or minus 180 kilowatt hours. The weather outlook is clear at 28 degrees Celsius peak. The hourly generation profile lets you track the forecast versus actual, and you can see the actual data through the morning hours and forecast only for the afternoon. The per asset breakdown shows each unit's expected output and the model version that produced the forecasts. The model observatory is where you manage the machine learning models behind the forecasts. The production model section shows you the model name, deployed date, the mean absolute percentage error, R squared, and total number of observations involved during the training process. 2 Challenger models are currently under evaluation. Version 3.3 RC1 with 3.8% MAPE, and version 3.3 RC2 at 4.1%. When a Challenger beats production, you can promote it with one click. And if something goes wrong, you can easily roll back to the previous version. The dashboard told you inverter 5 is down. Maintenance diagnosed the fan stall and thermal shutdown, and gave you a repair plan with parts and assignment. Forecast told you what to expect tomorrow so you can plan around the outage. And Model Observatory ensures the forecast keeps improving. That's the OODA loop in action. Observe the fault, orient with AI diagnosis, decide on the repair plan, and act with parts and scheduling.